This is the double disc version of the Sanyo MBC-550, the Sanyo MBC-555. Launched in 1983, many regard it as the first truly affordable IBM PC compatible, and in many ways it was.
In January, I read a classified ad that went something like this: for sale, MS-DOS and IBM compatible PC, $995. I'd been regularly reading the classifieds for 3 years and knew this price was a typo. The correct price must be $1995 or $29.95. I rang anyway, and the salesman told me that $995 was the correct price. What's wrong with it? Went through my mind.
These are the words of Bill Sudbrink in the August 1984 issue of the popular computer magazine Byte. So why was this PC so cheap, and what, if anything, was indeed wrong with it? To answer that, we need to start with the original IBM PC and discover what compatibility really meant in the early 1980s. August the 12th, 1981 is a date to remember, the date the IBM personal computer was launched. Although IBM had no idea at the time, this design would quickly become the industry's standard all over the world. Based on open architecture, most of the PC's components were off-the-shelf products. The only real proprietary piece of hardware was their BIOS, the basic input-output system that is really at the core of how the system works. Everything connected to the PC, from the graphics circuitry to the keyboard and CPU, are managed by the BIOS, initially at least. You might need an operating system to control the PC, but the BIOS provides the boot sequence and runtime services to enable it. You might suspect then that such a crucial component would be copyrighted by IBM, and indeed, due to how quickly IBM put the machine together, it's really the only component that is, although there was a grey area around that to begin with. Competition was already hitting the market, but with the IBM already the main player in the American business world, they needed to serve up some goods. So combined with their contacts and trusted name, their new personal computer, breaking from the norms of huge mainframe systems, was quickly adopted. The most popular bundled operating system was the IBM-branded PC-DOS 1.0, licensed from Microsoft in a hastily arranged deal. This ran on an Intel 8088 4.77 MHz CPU with up to 64 KB of installed RAM. It was a pretty capable device, which to many more than warranted the entry-level $1,565 price tag, or closer to $3,000 if you wanted a disk drive and a reasonable amount of memory. But for some, it either wasn't quite powerful enough for their needs, and for others, especially small business or home users, simply wasn't affordable. Of course, third-party manufacturers were quick to realise this and address the situation with their own designs. Here's one of the first. This is the Columbia Data Product MPC-1600. Launched in June 1982 and retailing for $2,995, it's an incredibly close copy of the IBM PC, apart from two factors. The first, that it's superior, sporting 128 KB of RAM as standard, an additional 3 expansion slots and 2 floppy drives. The second is that the BIOS has been reverse engineered and then built from the ground up in a clean room fashion. This is where a team with no prior knowledge attempts to recreate the functionality of the original BIOS from a blank sheet of paper. Now, this method nicely circumnavigates any copyright issues, however, it's a timely and expensive process that many competitors couldn't commit to. Some went down the route of directly copying IBM's BIOS chip. This included Taiwanese but also American companies like Eagle and their Eagle PC. However, for those who wanted to test this dangerous route, the Apple Computer vs Franklin Computer Corp legal case decided in August 1983 that binary code should also be held under copyright, thereby closing the grey area I mentioned earlier. In terms of operating system, Microsoft's favourable licensing agreement with IBM allowed them to license DOS to other computer manufacturers without issue, paving the way for even more clones with their own branded DOS operating system. Some of these clones would go down a different route entirely, and one which Microsoft had actually planned and indeed hoped for in order to completely topple Digital Research's CP/M as the previously leading micro OS. Here's one of them. This is the Apricot PC, and it's one of the first computers to incorporate the Sony 3.5-inch disk drive, giving a single-sided capacity of 315 kilobytes. It also has a whopping 256 kilobytes of RAM and an Intel 8086 processor, offering a full 16-bit data bus compared to the 8088, which offered only an 8-bit one. Now, this isn't a clone per se. It might have very similar hardware, but it doesn't incorporate an implementation of IBM's BIOS. However, crucially, it does run Microsoft DOS. In fact, it's an OEM version of DOS specifically designed for this machine, adapted for a low cost by Microsoft themselves. You see, Microsoft had a vision where it would adapt bespoke versions of DOS to run on different computer systems. Programs would run within DOS and rely on the DOS application programming interfaces to communicate with the underlying hardware. This so-called hardware abstraction layer meant that a program that runs on an IBM PC under DOS should, in effect, have no issue running on this Apricot machine, or on any other Intel-based system running its own implementation of DOS. This universality meant that these machines quickly obtained the tagline of having IBM PC compatibility, or data compatibility, but almost always stipulated as being only to certain degrees. You see, it was much faster, and indeed even necessary in some cases, for software to talk to the machine's BIOS directly, or even low-level hardware. For example, DOS may have had adequate text functionality, however for software requiring graphics or a flexible cursor that could be moved anywhere on screen, software developers would often choose to address the IBM PC hardware directly, given it was the leading brand. Hence, these other rip-off machines were not fully IBM PC compatible. But these were like the Wild West days of PC innovation and architecture. Opening up your favourite Popular Science or computing magazine would blast you with kilobyte figures, processor speeds, disk drive sizes, on-screen colours, and a slew of manufacturers and operating systems to boot. So if you could bring a well-specified PC to market running DOS for less than $1,000, then it was sure to make some serious waves. And this is where our Sanyo MBC comes in. Japanese electronics firm Sanyo, founded in 1947, may have been more familiar with domestic appliances and hi-fi manufacture, but in 1982 had taken the computing plunge and launched the CP/M-based MBC-1000 series, running on a Zilog Z80 CPU and incorporating a green screen with up to 2 disk drives. However, the rising dominance of the IBM PC meant they would have to change both suit and architecture. And so, originally launching in September 1983 as the MBC-550 in Japan, this desktop unit would quickly make its way to Western and Australian markets, where it was aimed at the thrifty business or power home user. This sleek and silver package quickly turned heads for hitting all the right notes. I actually sourced this particular unit from eBay for just under £300, which, it's not in too bad shape, but it does need going over, especially the keyboard. You can see the grime on the keys there. It's not nice, but sugar soap is perfect for removing all of it. I like to use these wipes with a slightly dotted surface, which helps with the cleaning. Look how that dirt just comes right off. Oh yeah. Same for the base unit, a quick go over with the same wipe and it looks almost as good as new. If you've got a magic eraser, they're pretty good for getting rid of any leftover marks as well. Okay, I think we're good to go. Featuring 128KB of RAM as standard, a single 5¼ disk drive on the 550 model or double on the 555, a maximum screen resolution of 640 by 400 with up to 8 on-screen colours. This was a well-equipped box, with only the 8088 CPU clocked at 3.58MHz instead of 4.77 on the IBM PC, coming in under spec. So all this for $1,000 must have seemed like an absolute steal. Comparable clones were coming in at least double that, and an equivalent IBM PC cost around $3,500. One of IBM's answers to these low-cost clones was the PC Junior, launching in March 1984 and offering CGA improved graphics capability, but even this machine, aimed at consumers, was still almost $1,300, and that's without a monitor or disk drive, meaning users had to make do with the cassette interface.
From IBM, the computer that's growing by leaps and bounds.
So how did Sanyo achieve this amazingly low price? Of course, for $995, Sanyo didn't ship a monitor as standard, but at least it damn well came with a disk drive. But a lot of it is in that lower clocked CPU. In NTSC regions, the 3.58MHz is the same as the NTSC sub-carrier frequency and can easily be arrived at from the master clock. It meant the whole system ran slower, paving the way for cheaper components and a more efficient design, including a transformer power supply instead of a more expensive switching unit. At the rear we're provided 2 video connectors, an 8-pin RGB and composite video out, meaning this beauty can be hooked up to almost anything, although for a number of reasons which we'll get to, the composite output is only monochrome. For $199 you could bag the matching monitor for that connection, or for $749 you could have the full colour RGB monitor. This Sanyo CRT70 fitted perfectly on top. Or, if your name is Tony Montana, you could just use a whole bank of them to display security camera footage. Or you could just use a cheaper alternative. I'm using a rather appropriately paired Sanyo TV/monitor. You would more commonly find this paired with Sanyo's MSX compatible MPC-100, which came out just after the MBC, but in lieu of the CRT70 it still looks the part on top of this base unit. Back here we've got a Centronics printer port, a 5-pin DIN keyboard socket that isn't IBM compatible, and also upgrade slots for a joystick connector, line which is actually for an RS-232 serial port, and an expansion card. You'll note there's no standard serial or mouse inputs here. Peripherals in that regard are somewhat limited. We'll come back to that shortly, but for now let's boot her up. Sweet, sweet smell of electronic components warming up. The sweet, sweet sound of the disk drive kicking in. Oh yes. Now, in an IBM PC compatible, here's the point where the ROM BIOS goes through its paces, and an attempt will be made to find an operating system. In the case of the MBC, most of the 8KB ROM is actually empty. There's 1KB of keyboard lookup tables, 2KB for the font, and just 256 bytes of code, which initializes the base hardware and loads the first sector from drive A, which, unlike Western convention, is located on the right-hand side. And this is where it gets interesting. At least it does if you're me. You see, the boot sector of the disk actually needs to contain the rest of the ROM, which is loaded into RAM. This provides access to many features you'd find in the IBM BIOS, including video on interrupt 10 and keyboard on interrupt 16, etc. But it means that the main bulk of the BIOS is now referenced from RAM by DOS rather than ROM. With that out of the way though, Sanyo's version of Microsoft DOS can boot and we're good to go. Version 1.25 no less. So we've just loaded off the DOS disk, but if we reboot the computer without it, you can see the problem of having no BIOS is there's nothing to show. The computer is literally looking for the first sector on this disk to load the rest of the BIOS, and it doesn't have it, so it just sits here in this blank state. Put the DOS disk in, and away we go. Those of you paying attention may at this point realise this means the MBC disk format is actually slightly different to that of an IBM PC, although it's not advertised as so. But although we can't boot from an MS-DOS disk, the MBC can read a single-sided DOS disk formatted from an IBM PC. Looking down at the keyboard, we've got an 81 key slab that matches the base unit perfectly. I really quite like this silver kind of effect. Rather than 12 function keys, they're condensed into 6, accessible using a key command, as you'd find on the Commodore 64. Interestingly, there's no Alt keys, which are really quite crucial for many standard DOS programs, especially where you need to access menus. Sanyo has instead opted for holding down Shift and Control to mimic the Alt key. If you're used to an IBM PC layout, you may also find the caps lock and control positioning a bit odd. But other than that, the keyboard is very nice to use and offers a satisfying switched click provided by the almighty 3rd generation Fujitsu leaf spring, which, although providing good feedback, is also quite quiet and provides incredibly smooth action. It's quite a thick key, quite a thick plastic around the edge. Nice and solid, nice and sturdy though. So, these are the disk packs we get with the Sanyo MBC. The first one contains MS-DOS version 1.25 with basic 1.31. We've got WordStar, disk 1 of 3, disk 2 of 3, and CalcStar on the 3rd disk. The other set of disks is MailMerge / SpellStar, DataStar, your database system, ReportStar, disk 3 and disk 4. So you get quite a comprehensive little office system here. Now the machine's instructions came in a folder like this, rather nice. Look at that. Oh, very 80s pattern. The manuals were reportedly incredibly difficult to understand. They were laid out in quite an incoherent fashion. Maybe that's some sort of a problem with translation. We've got some nice pictures like this. We've got someone happy in his office with DataStar. How to use this training guide. You know, there's a lot in here. So this is the main DOS disk, and we've got command.com, check disk, debug, edlin, filecom, format, disk copy, basic, and demo.base. So not many utilities, and you know, this is a very early version of DOS. We can run basic. This is kind of like the basic that was built into IBM PCs. It's the precursor to GW Basic that would become bundled with DOS going forward. We load up the demo. What we get here is a graphical demonstration. Pretty straightforward. It draws the Sanyo logo and then we get various demonstrations. It shows the character set and different graphics it can produce. Of course, this would look better on a colour screen. It's worth noting that the ASCII character set on this machine is indistinguishable from an IBM PC, or as much as I can see anyway. Now, I mentioned earlier the Sanyo having a basic beeper style speaker, but I'm going to show you a demonstration of the differences in the hardware using that. If we use the basic commands sound or play, this computer will completely ignore them, no matter what parameters you put in. But if we access the sound hardware directly, so let's type in 440 next X and we run this. Right, let's try that again. There we go, we get a machine gun style sound, which is nice. So we can produce effects from the built-in speaker, you just have to go around it a slightly different way to the IBM PC sometimes. Okay, let's give WordStar a look, shall we? And this is our basic word processor. We get a print test file and we get the menu at the top, which you can access via various key combinations. And we can scroll using the directional arrows on the numpad. Yeah, it's a word processor. How do we exit? Exit. How do I exit? Alright, CalcStar. Copyright 1983 Micro Pro International Corporation. Alrighty, so here is our spreadsheet. File name, make sure it is saved. So you have to know the file name, so I have to go back and check the directory. I go demo.csd. Let's load that. Demo.csd. And we have a spreadsheet. Now we can control this. Right, Control and X will go down. Control and D will go right. Etc. It's a spreadsheet program. Excellent. Oh, I love that clunking disk switch sound. Datastar. The form definition file does not exist. Do you want to create it? Yes, I do. This is a database program. We could spend all day on this. Basically, we've got all the essential Office applications with this system, which is nice. And especially for the price, it was an absolute bargain. That's why many businesses and many home users, of course, bought it.
While we're here, it's worth mentioning that when writing to disk, the system clock actually pauses, meaning it can very quickly fall behind real time. But there's no actual battery in the unit, so you have to enter the date and time on each boot. I guess we should take a look inside and see what's powering this thing.
Now, as you know, buying this old equipment is not cheap, so today's sponsor is Skillshare, and it's a learning service I'm really excited about going into this year, mainly because I'm using it. If you watched my last video, you probably heard me talk about how I'm trying to improve production this year and really step my game up. You know, this channel, as well as being about these stories, it's about the emotion behind the technology. And courses like Dan's creating a modern cinematic documentary with soul are really going to help me bring that to camera. I'm already halfway through this course, and the way it's laid out is so incredibly clear and straightforward. I'm even starting to play with lighting effects already, so it's something I'm really excited about. But this is Skillshare. It offers so many different life-enriching courses that you're bound to find something you can get your teeth into. Right now, Skillshare is giving away 2 free months of premium membership to help you explore your creativity if you click the link in the description box below. And after that, it's only around $10 a month, which is one of the reasons I'm on board. So why don't you join me on this journey into 2020 and let's see if we can learn something amazing and really step our creativity up. Thanks for watching. Let's get back to the video.
So that is the 8KB of ROM I mentioned earlier. Nearby there's a large, vast array of discrete logic chips. You can see our 128KB of RAM seated there, although actually this one looks like it's been upgraded to 256KB. Nice. Although I believe technically it can address up to 960KB with an appropriate expansion card. There we have the 16-bit arithmetic calculating Intel 8088. Slightly crippled by standard 8-bit bus and underclocked speed, but it does have an optional 8087 maths code processor slot there. For the display, the RGB output is generated by this HD68A45, which is a Motorola 6845 clone, and it roughly approximates CGA graphics, but is different enough to be incompatible with almost all IBM PC graphical programs. Sanyo's answer was for approximately $200 you could actually add true CGA compatibility via that expansion slot. The NBA's CGA card is incredibly rare, and it also requires a different version of DOS that pushes the display through the CGA card's 9-pin TTL port rather than the default ports. but it does allow you to use a few more graphics-based IBM PC compatible programs. Without it, the system can actually drive a composite display and RGB simultaneously. The reason composite is only grayscale is that the red signal plane becomes blink, and blue becomes brightness. Also, given the regional TV signal differences, and differences in the colour carrier signal, it's easier to omit colour from this output to give a universal standard. As for sound, well, like an unexpanded PC, we're limited to basic beeper. Endearing if ear-wrenching. Worth noting is that there's also an exhaust fan for the power supply, which was reasonably rare at the time, but means the MBC makes a reassuring whir in operation. Also, as mentioned before, it's weird to have a transformer rather than a switching power supply, but whatever works. There's actually a connector on the motherboard for a 5MB hard drive, although it wasn't promoted at the time. A company called ThoughtWorks produced hard drives up to 20MB in configuration, with starting prices at over $2,000. So they certainly weren't cheap, and for that reason they're rarer than the CGA cards. These machines are so much more simply built, it's so easier to work with. Take apart, put back together. Oh, except for that. During 1984, approximately 70 bespoke software packages were available for this Sanyo line, with some 20 software houses actively engaged in bespoke software. If you add this to the IBM PC software that is compatible, then you end up with quite a respectable library to choose from. Some of the IBM PC games which worked included Zork 1, 2 and 3, mainly because they're text-based games, and you can operate them through the DOS APIs. But there were also bespoke games built specifically for the MBC, including Thunder Chief, Demon Seed, and Time Bandit by Mictron. Unfortunately, I don't have any of these, but thanks to the power of the internet and a wonderful gent named Leo of eriscreations.com, I can show you a few clips of it in action. The biggest hurdle with running actual IBM PC games, of course, was the graphics. The way each system addresses the monitor memory map is distinctly different, so unless you have a CGA board, compatibility was very hard to find. So then, here's a machine that launched to a lot of praise, a lot of good press, and seemingly pretty solid initial sales, which was certainly in the tens of thousands. It was also quickly adopted by the Washington DC based National Radio Institute. Previously, they had based their training course around a TRS-80 Model 4, but now you could effectively learn to build your own IBM PC compatible from the ground up. Presumably they would ship you the parts and the course documentation for the membership fee, and you could get cracking with your soldering iron and potentially zero previous knowledge, because that doesn't sound like a recipe for disaster. I hope that's not how my model came into being. The NRI would advertise often in magazines such as Popular Science, giving the MBC additional coverage. There was even a dedicated US magazine for the Sanyo MBC called Soft Sector. This issue is from April 1986, demonstrating that the user base was still present and active as the 80s went on. However, despite all this, the MBC, like all computers of this ilk, would die out in favour of true PC compatibles, such as Compaq and others, who made use of the highly compatible Phoenix Software Associates or American Megatrends BIOSes. At the lower end of the scale, Tandy would find market share with their 1000 model based around a PC Junior, but actually selling much better than IBM's doomed home foray. In August 1985, Sanyo reported selling off their remaining MBC-550 inventory so they could concentrate on new products which were reportedly 99% compatible with the IBM PC. The first of these was a luggable named the MPC-775, retailing at $2,599, with an XT clone, the 885 released shortly after, sporting dual drives, 256KB of RAM and an 8MHz CPU. Even so, the 99% figure seems a little optimistic in hindsight. The 8-Bit Guy has done a video about the 775 machine if you want to go down that route. The MBC name would, however, continue into the 90s with a range of true IBM PC compatible laptops. The MBC-18, for example, is a 286-based machine which to all intents and purposes is a decent early 90s laptop. It's good to know they got there in the end, before returning to the safety of home entertainment, personal stereos and home appliances. Today they are a subsidiary of Panasonic, with the brand dwindling out into insignificance. But still, you've got to hand it to them, they sure knew how to make a damn fine looking piece of equipment. Thanks for watching, have a great evening.